Okay, you can go on. You can go on.
All right, so we have example.txt. I don't want to keep altering this document. So instead of touching it, I just duplicate it and continue my operation here, right? Because I really don't want to touch this document. And say I have started working on this and it has gotten to a point that I feel like, you know what, I don't want to also continue altering this. I can go, I can keep creating more documents that I keep building on, right? The idea is that I want a situation where I can always go back to the previous version that I have. So it's not stress for me to come back to this guy and say that, okay, everything I did there was a mistake. So let me just come back here and start and continue my work. So someone might say, why not just use Control Z? Because when it comes to Control Z is like the current file you are working on. Because I could have as well come to this place and continue my work and realize that, oh, what I did earlier was actually right though. I have to now delete and start writing again. But in this case, I can easily move between the versions that I've created for myself. So yes, welcome to Git. Git is a version control. So Git is actually a version control system that records changes to file over time, and it allows us to record specific versions. So as I was saying earlier, before now we used to have BitKeeper, and even the creator of Git himself used BitKeeper. There was a time that BitKeeper is a proprietary application, right? But during their collaboration with the Linux Foundation or the Linux project, they had an issue, and then BitKeeper stopped being free to use. Then this guy, Linus Torvald, was like, BitKeeper was even stressful to begin with. So they took learning from everything they knew about BitKeeper, then used it to create Git. And since then we have Git. So Git was also created by the same man that created the Linux, like the Linux kernel, right? So yes, essentially, instead of duplicating your file over and over again, Git is just that tool that helps you get this done, right? You don't have to keep duplicating. The name of your file does not have to change. All you just have to do is just initialize Git in your command line. So why use Git? Of course, we've covered that. So it helps track changes. We've covered that one. But one of the things that Git prides itself at is the fact that it helps collaboration. It takes collaboration, and this does not even mean that Git won't work when you have people that are distributed all over the world. Before, applications like BitKeeper, before now, you would have to be connected to a server even before you can work. But when it comes to Git, every developer can literally pull the same copy of files that they have in a remote location and pull it to their local. Off the top of my head, advantages include, you could be on a flight and still work on your project. You don't necessarily have to be connected to the internet to make changes to your project. When you have access to internet, then you can push your changes. But you can work from anywhere. You can even work from a laptop that is not your own, as long as you have it aids distribution, collaboration, and it's also easy to revert to your previous state, right? Also, the fact that we can move in between versions, right? We can move to previous versions, we can come back to the existing versions. It means that you can always experiment. Say you are trying to work on a feature and then you realize that, oh, you've made a mistake somewhere, or you just want to try out an idea. You can easily create a separate branch. Would still go into the meaning of branch later on. You can easily create a separate branch, do your experimentation there. If it works, fine, you come back, you match it back into the main branch. If it doesn't work, you can discard it, then keep working on the branch you've been working on earlier, right? So I'll be moving in between the slide and my terminal, right? So Git generally only adds to data, and what I mean by that is there's a way that Git tracks changes that you've done or changes that you made to a file. So Git uses something we call SHA-1. So SHA-1 is like hash. People in cybersecurity would be very familiar with hash numbers. Hash numbers, in a way, is the way we design technology to help us determine the integrity of files. So if I have a hash number for a file, if I generate a hash for a file, the moment you alter that file, the hash number is going to change. So that means that it is easy for Git to know when you are trying to manipulate a file or when you are trying to corrupt a file. So I mean, that's kind of like the integrity part of Git. So core concept. Before we get to the core concept, I'm going to initialize Git. Is as easy as typing git init, like initialization, git initialize. So but in this case we have git init. So it said initialize empty git repository in, this is my part. Okay, I'm in the wrong folder actually, so I'm just going to, and that's even good safe. So it has initialized Git in this repository, but I don't want it in this repository. How do I know that Git is in this repository? It's very easy. I just need to list the file I have here. So there's a way that our machines used to hide hidden files. So if I do the normal list, I will not see all the files that are in this folder, right? But if I had this -a flag for Linux and I also want it in this format, I just do this. I can see that there's a .git here. So this .git is where Git keeps all the metadata. So the moment I initialized Git, it will create this .git folder. I can take away Git from this folder by just deleting this .git folder, and that's what I am going to do so that I can go to the right folder that we are working with. So rf-rf.git. This is just me deleting the .git folder, and if I list again, it would have left my folder. So I'm going out of this place. All right, I'm in the right folder now. So I'll initialize Git here. Okay, not here. Let me enter examples. Okay, so I've initialized Git there just so that we are sure. I'm going to list every file in this folder, and I have my .git here. So it said initialize empty Git repository in this folder, right? So I'm working in the folder, I initialized Git, and then it's telling me it's a repository. So what do we mean by repository now? So honestly, repository is just a folder. The only difference between your repository and a folder is that your repository is being repository is a folder that is being tracked by Git. So anytime you initialize Git in a folder, that folder becomes a repository, right? That means that you can have a repository on your local laptop as well as on a remote computer, right? So we've made that clear. Repository is the same thing as your folder, but in this case, it is being tracked by Git. What do I mean by being tracked by Git? It means that you can easily tell Git to take note of certain files, to take note of certain things that you are doing in that folder. So you can give Git the permission to be aware of the files you would have in that folder. But before I continue, I'm just going to take out this file. So let me delete. So I only want to work with example.txt, right? So we've taken care of repository. Let me see the other concept. Okay, so when it comes to working with Git, right? The files that we have for Git can be in 3 states. The first one is unmodified, right? The second one is modified. Then the third one is staged. So unmodified means that you have not touched that file, right? Modified means that you've made corrections to that file, like the way we have example.txt, where I have my name is Okoyemi, right? If I should add something to that file, then that means that I have modified it, right? Stage is a case where I am preparing those files to be saved by Git. So that brings us to 3 sections when it comes to working with Git. I've already mentioned 3 states three states of file whenever we are working with Git. 3 sections for Git are the working directory, the staging area, and then the Git directory. So currently, my folder, this place I have example.txt is a working directory, right? It's like my workspace. It's where I am working on my files and stuff like that. The moment I invoke a Git command, there's a particular Git command that helps us move it into the staging area, and that's git add. So the moment I use Git to add that file, I would have moved that file to a staging area, right? And you can only specify the file that you want to move to staging area. You can also add every file that you have in that repository to a staging area, right? Now, the moment you commit that file, so you can only commit a file that is in the staging area, right? There are ways to commit files that are not in staging area. It will require an extra argument to your commit command, but for you to commit a file essentially it has to be in the staging area, right? And the moment you invoke your commit command, that's like git commit, you move that file to the Git directory itself. You give Git all the information that it needs concerning that file. So tracked files versus untracked files. As I said earlier, tracked files, Git is already monitoring it. They can be in the state of unmodified, modified, or staged. Untracked files are files that Git has no idea of at the moment. Now, currently my example.txt, Git does not know about it. And how will I know that? I can easily type Git status. So if I enter Git status, you can see that Git is literally telling me that we have untracked files. What are the untracked files? Example.txt. So what Git is telling me is that this file is in your folder, but I am not looking at it. I don't know what you are doing to it, right? For you to now let Git start tracking the file, you can invoke this command. In short, it's even giving us the command to use. You can do git add your file like example.txt. If you want to add everything, you can just use git add dot, and Git is going to add every file that you have in that repository and start tracking them. So I'm just going to invoke this suggested command from Git to add our file example.txt. Sorry. So I'll do enter. Now it looks like nothing has happened. So let us check our status again. Remember that it was under untracked before, right? I'm going to do that Git status again, and now we can see that Git now knows that it's a new file. Now if you look at this place very well, it's saying git rm -cache, then your file to on stage. So that means that we literally just move this file from the untracked stage to the untracked phase, rather, to the staging area. So we've staged this file, and Git is now aware of this file. So currently this file should be in the unmodified state because I have not edited it, right? The moment I had something extra, say I am 5 years old, right? This color has changed to yellow from green. Every how do I put it? This is Z, right? But what's the name they call all these tools? These tools that we use to edit code anyway. I don't know why the name just skipped my head right now. So for example, VS Code, now we have a different way of showing you that you have modified a file. I think VS Code used to even put M at the front. So if it is unmodified, VS Code is going to put U. If it is modified, it's going to put M. So in my own case now, the color just changed to yellow, right? So if I do git status again, it just told me that we've added this file, true, but this file has now been modified. So for me to include this change I just made to this file, Git is aware that I've touched that file. And remember that we mentioned something about SHA-1, that's like the hash. So it means that the hash that Git previously had for this document has changed since I have modified it. So Git can easily tell that somebody has attempted to make changes to that file, but the change is not there yet until I had what's it called? I had the changes. I have to do git add to add this new change I have done to that file, right? Because if I should go ahead to commit that file directly, this change that I made would not exist in my file. So I'm going to invoke my git add command again, add it in, and we are back on green, right? So let me just see. So we've dealt with tracking and the untracked, the tracked, and the modified and stuff like that. Now we have the commit. So after adding your file, the next thing to do is to commit it. Commit is just like saying that I want to save the state of this file. This current state, I want to add it to what we have, right? So it's as simple as just saying git commit. But because Git wants a situation where you can easily remember your states. I mean, like in your own words, you need to add a message. So you pass the message with -m, then space. I'll put it in double quotes, right? So I can just say that this is an information. Sorry, yeah, about Okoyemi, right? So there's a limit to the number of characters that this guy can actually take, but I know there are other ways that you can use to increase your commit message. So this thing I'm writing here is called a commit message. The moment I press enter, it's going to save the state of my file, right? And look at it now. It has given me the hash number of this file, the hash value. It's giving me other informations. One file change, there are 2 insertions, then it's a create mode. So there's a way for you to check all the previous commits that has happened on a repository, right? And that's one of the beauty of Git. Say for instance, I'm working on a repository and we also have maybe an engineer B working on another on the same repository. The moment I pull, we'll still get to like pull and push, right? But the moment I try to move that file to my local repository, I move all the history of commits and everything they've ever done in that repository to my local repository. So let me just clear my screen here. So we are going to look at the history of commits that has happened. You and I both know that we only have one commit so far on this repository, and that was the one we just did. So to see previous activities on a repository, you could easily do git log. That will give us a log of history that has happened on that repository or on the file, right? So yeah, this is the hash number we are talking about, right? And then this was the commit message. So the moment I see this, I can know that, oh, this was what they changed when what they changed about this file. Say for instance, now let me try to edit this guy. I am not 5 years old. Let's say I just remembered that I am actually 10 years old, right? And I need a way to just add this guy. If I do git status, I'll keep doing git status. It's not really necessary, but I'll keep doing it so that we can see the states that the file keeps moving in, right? So it has changed to yellow. If I do git status, it's going to tell me that I have modified it because I changed from 5 to 10. And let's recall that the previous hash we had started from BE5F9, right? So I'm going to add this file again. Since this is the only file I have in that repository, instead of typing example.txt, I'm just going to use dots, right? Because there are no other files in that in this repository. So I do this to add my example.txt, right, then I can just go ahead to, let me do git status again. I wanted to commit actually. So git status, now it is modified, right? So I will do git commit to save the current state of this file, right? So if I do git commit, now I need to add my message. I changed something, right? I now have to put the message. I corrected the age, right? So if I press enter, it tells me that, okay, we have one file change, one insertion, one deletion. So to Git, when you change a line, it actually looks like you are deleting something and then you are making another insertion, right? So Git is not looking at I am years old. Git is looking at it as a full complete like line. So the moment I change one thing, it looks like I took out that line and then I wrote something new entirely. So considering this now, sorry, I didn't intend to do that. Okay. So looking at this now, I can easily just try to get our git log again and see what the log looks like now. So we can see that we now have two commits with different hashes, right? So I have my first commit here. This is an information about Okoyemi, then I corrected the age, right? So if, for instance, I pushed this repository to a remote repository, this is currently my local. So the repository on your laptop is called local. The one on a server or a computer that is not yours that you're working with is called the remote repository, right? So say I push this folder to a remote repository and somebody else were to pull that same folder to their own local and they do git log, they will actually see all this information about that file. So git log helps you see the history of changes that has happened on that file, right, or on that repository. Now there is something we can see here. This is called head, like, right? So how do I explain it? Head is head point. So basically head is that term that just describes that I am currently pointing to your most recent commit. So head is always pointing to your most recent commit, but it doesn't point to it directly. Majorly head points to the branch, then the branch points to the most recent commit. So the moment I try to move to my previous what's it called, to my previous branch, right, to the previous commit I had, I might be detaching the head from the branch directly to that commit. I'm going to do it. I know it sounds like jargon, but say for instance now, I have corrected the age here, but I realized that, oh, you know what, I want to keep working with the previous file that I have. I can easily copy this hash value, right? So I'm just going to copy the hash value. Then there's a command we use whenever we are trying to move in between something we call branch and even your commit. It is called git checkout, or I could use git show. So I'm going to use git show first. So I'll use git show, then paste the hash that I copied. So this is going to show me the content of that commit. So I can use my hash number to get the content of the previous commit I made, right? So this is telling me that this was made 5th of July 802. Okay, 802, and the commit message was this information about Okoyemi, new file, So I added my name is Okoyemi, and then I added I am 5 years old, right? So git show will only show me the file, right? It will show me the history or whatever that has happened during using that hash value. But if I actually want to go to this previous commit, I have to do something we call checkout. So I'm checking it out. Like, I just like those things are looking like English. So let's check out that commit, right? So git checkout. I'm going to paste my hash file, right? So enter, right? So it is telling me that you are now in detached head state. I mentioned that your head is always pointing to the branch, or in this case, our branch is main, right? So head will point to main, main will point to your commit, the most recent commit. But in this case now, I have moved my head directly to what's it called, to the previous commit I made, right? So I'm in the detached state. You can look around, make experimental changes and commit them, and you can discard any commit you make in this state without impacting any branches. So at the top here, you can see that I'm back to I am 5 years old because I moved to the previous commit. I don't have to change the name of the file. Remember that when we started, I had to make a duplicate, correct it, then I have to manually start switching to the different state of the file. But in this case, I don't have to make changes to I don't have to create a duplicate. I can just literally move between the files using like my hash, right? So we have the previous commit we made. I can continue my work here if I want, but in this case I actually don't want, so I'm not going to do anything. I just wanted to show us how to move in between the files, right? And it's also the same way you move in between branches, but for now we'll work with main branches, and then we'll talk about other branches when we get to the like Git flow and something like that. So I don't want to do anything here. I would just like to go back to our main branch, and that's actually main. So I will do git checkout main. Doing this will take me back to our main, and then you can see that we are back to the previous state. We now have, my name is Okoyemi, I am 10 years old, right? So that's it about committing and moving in between your commits, right? So if I still do my git log, I'll still see the history of commit so far. Now we can see that our head is back to the main. So head is always pointing to the most recent commit. So if you move by one step to the previous commit, your head will have to move to that commit, while your branch will still remain in the updated file. And if you don't remember the hash, right, and you want to move in between your commit, you don't necessarily have to come here to copy the hash. You could just do git main, then put a caret, right? If I put a caret, it takes me one step behind, right? If I do this, is sorry, git checkout. So git checkout main. So it takes me one step behind, right? You're in the detached state, and then we can see that we are now back to our previous one. Say I have like 2 steps, I can easily say git checkout main caret. So depending on the number because it's not every time that you load the hash or you can remember the hash, but Git has devised a means to just go through the different commits that's happened so far. And I think there's another one that they have, I can't remember, where you pass the number of commits. Let me go back to main, right? You pass the number of commits that you want to go to. Okay, I'm not sure I remember that correctly, but there's something like this where you can pass, you cannot keep doing caret. So you can easily just pass the number of commits you've made, and then it takes you to like that version that you're specifying. So I don't want to, okay, let's just talk about what branch is. So branch is like an independent line of development. Oftentimes we have the main. Before it used to be master. That's kind of like the way it sounds, master, like that's a master branch. Nobody should actually really mess with this branch. So branch is the line of development you are maintaining. It's kind of like the working code that you have. Say for instance now, our WhatsApp, the code that WhatsApp has that is currently running will be in a master branch. So what it means is that we cannot have people making changes to that branch, because every change you make is going to reflect directly in production, right? And we don't want that. Imagine that there's a case where I've seen a situation where they were supposed to be tested, but it actually got to the main branch. And what happened was that there was a loophole in the current the current code they have, where people can you can add beneficiary without password, and then you can send money to the beneficiary without entering password. So that loophole kept taking money out of the user's account, right? So you shouldn't work directly with the branch. So we oftentimes, most organizations have a structure where they run a master branch. That's the one that we have the production code. Then we duplicate. We have a parallel branch. That's like the development branch. So everything that we have a master, we also have them in the development branch. Now, say somebody like Senior Chijoke now wants to work on the development branch. He can easily pull the code from master or the main. It's called main now. They've fizzled out that master terminology. So he can pull the main, right, so that he's sure that he has all the working code, right? Then create his own personal branch. When he creates his own personal branch, he can call it like a fix, hot fix, or something like that, or bug fix and stuff like that. He creates that branch, he works on that branch, then he pushes that branch to the development line. So it is on the development line that they can know that, okay, we have an updated code and stuff like that. They could test from there, and if they are satisfied, they can now merge that branch into the main branch. All these things sound gibberish, but if you have seen the Flash before, they were talking about the concept of timeline, right? So I'll just adapt their explanation. I do not continue because they started doing nonsense later on. So they have like a current timeline, then they have alternate timelines, right? So there are some cases where Flash will keep running, right? And then it's so fast that it will now create a branch of a different timeline. Now, in those timelines, it might press pause and do one funny stuff. Then they now have to start looking for a way to merge the timeline that he has created back into the original timeline, right? That's essentially what's actually happening when it comes to Git branching. So we have a timeline that we are working on. We don't want to make mistakes on that timeline, so we create a branch of that timeline, make our experiments on the new branch that we have, then we can merge it back into the previous the previous timeline. Let me see what's next here. So okay, so we are just going to demonstrate the creation of branches, and then we will merge so that we see we see how it works practically. There are actually two different ways to merge. That's the actual merge, then the rebase. But I will only be talking, because of time, I will only be talking about like the actual merge alone. They are only different when it comes to the dialog, like the history of commit, right? For merge, okay, I'm just going to show what merge does, right? So clear. I'm currently working on the main branch. How would I know? Very easy. I can type git branch, and it's going to tell me that I have the main branch, right? There are different ways to create a new branch, right? There are different ways to create a new branch. I can use git branch and the name of my new branch, and then I can use git checkout. Remember that we're using checkout command to move in between our commits. Yes, but there's a way that you would use the checkout that it's actually going to create a new branch. And there's also git switch, right? Git switch can also create a new branch, but git switch is actually a recent addition to the git commands. Not very recent, but it's in a way it's still experimental, so they might still be changing some syntax. So it's just good to just go with, say, git checkout or git branch. So I am going to create a different branch, and that branch will have the same history of commits that our main has. So it's as easy as saying git checkout -b. So our -b is for branch, right? Our -b is for branch, and then I will go ahead and type the name of our new branch. I'll just call it new -branch, right? Then enter. So in addition to creating a branch, git checkout will move you to that new branch, right? So it doesn't just create a branch, it moves you to the new branch. Let's try to experiment. Currently now, if I do git branch, you will see that it has moved me to the new branch. How would you know? It will have a star before it. So Git will always show you that this is the branch that you are currently working with. So whatever changes that I make here will not affect my main branch. So let's just quickly make a modification to the file that we have on this branch, right? I'm going to add I love sleeping. Well, that's partially true. So I will save. I just need to save this guy. So I'll modify this. I can do git status, right? So it's telling me that I've modified. Now let's add this file to the staging area. So if I do git status again, we can see that we now have it in the staging area. Then I'm going to commit it. So git commits. Kill. I did not put the message. Sorry. So I think m. So experimenting branching, right? So if I do enter, it would mean that I have committed this file, right? Now this file is on the branch, new branch. I'm going to go back to main branch and let's see what we have there. So git checkout main. That's me moving to main, right? So if I press enter, I've switched to main. You can see that I no longer have the I love sleeping there. I only have my name is Okoyemi and I am 10 years old. So say we are satisfied with what we have on that our new branch. Sorry, let me just do I'm going to do git branch so that we can see that we are now on main. So we are on main now. Our star has moved up. So say I'm satisfied with what I did on that new branch, right? I can easily merge my new branch into my main branch. How would I do that? Use the merge command, git merge. So I'm in main. I'm trying to merge new branch into main. I have new branch, right? And then enter. You can see that every information I had on my new branch has now moved into the main branch now. Now, think of the main branch as our production branch and then the new branch that we created as the test branch. We added a new feature and then we needed it to show up in production. So we just have to merge that file into into our production branch, and then we would have replicated whatever we had on the different branch on our new branch. Now, if I were to do git log now, I should have so I am on main, right? I am on main currently. I will have this was from main. This information is about the player. I corrected the age. Now experimenting branching is now in both main and on new branch, right? Let me see. Sorry. So match conflict can occur when Git cannot automatically combine changes. Most cases where I've seen a match conflict happen is where, sorry, I'm trying to look at that. Is where somebody has detached the head and then trying to merge a commit into a branch. Remember that earlier we detached the head where we add the head pointing directly to a commit instead of a branch. But in this case now we now have in this case we don't have that, so there are no match conflicts. Our main branch is also the same as our new branch, right? So Git workflow, the fundamental cycle is Git init, we've done that. Git status to check changes, Git add, and Git commit. We've actually gone through this. So essentially, this is how you initialize, you check your status, you add to staging area, and then you commit to the Git directory. I'm going to skip this. We've also done branching workflows, right? And that's where I talked about creating a separate branch that you can work with, right? You can create a separate branch, work on that branch, then merge your addition to the main branch so that it is available for everybody. Create a new feature branch. So this was exactly what we did, but in this case now, so let's talk about pull. Say we have, I hope I have something I can work with in my GitHub blog.
Before you move forward,
okay,
before you move forward, we only have 1 hour for this session,
Yes.
and we will not want to go past time. I know there is a lot to actually learn. I'm not sure we can unpack everything in this
No, we
tutorial,
can't.
because we
We
still have
can't.
to take questions and answers.
Okay.
If there's a
Alright.
way you can summarize all that we have learned right now, so that we can now do the rest another day.
Okay. All right. No problem. So essentially, we've covered the part where we have Git, a version control tool that helps you create different versions without essentially deleting the previous version. We have also talked about the difference between repository and folders, right? And repository being a folder that is being tracked by Git. How do we make Git track objects in your folder? Basically by running git init, right? Then you manually add that file using git add, right? So from there on, you can now be using your git commits, and it is very important to always commit before you switch to branches. So talking of branches, we talked about, we partially mentioned something about the Git workflow, where we have a case where you don't want to tamper with the person's branch. So you get the branch to your local repository, create a new branch for yourself, work on it, then merge those changes into the branch you've cloned. Right. What else? So I think that's everything. So we're not able to touch on GitHub at all. I'm very sorry about that. Yeah, so I think that's it. We can.
Thank you. Thank you so much, Opeyemi, for that. Please, let me see our reaction. Let's say thank you to Opeyemi. Thank you for that wonderful session. That was really a lot. I mean, at the point. Okay, Judith.
Yeah, thank you, Opeyemi. I
Hi,
wanted to
Judith.
say that those that have questions, maybe you can drop it on the group and Opeyemi will answer, leading to the next time we'll complete this topic. But for the questions we have on the chat, Chijoke has answered them, and I believe that he has done justice to the questions on the chat. So if you still have further questions, you can drop it on the group and Opeyemi will respond. Thank you. That's what I wanted to mention.
Yes, thank you, Judith. Thank you, Opeyemi, for that. Like Judith said, if you still have any question, you can drop it on the group, because it's almost 8:30 and we don't want to pass time so much, Opeyemi. And also, I'll just take note of all this stuff so that when next we'll be having this session, you can just pick up from there. Thank you so much for doing this. And thank you, everybody, for joining.
Thank you so much, Opeyemi. Thank you, everyone.
So that's the end of the video today.